The purpose of these next series of videos is to provide the tools for any builder to maximize structural integrity while minimizing the investment in materials, space, or effort. In essence, how to build better modular units. Design in nature is based on a do more by using less aesthetic, where sustainability drives evolution. Let that be our guide. It is my theory that understanding the modular building patterns that construct the fundamental structures of basic geometry offer a beginning catalog of natural design. At the core of design in nature is the concept of synergy, behavior of whole systems that is unpredicted by the behavior of the parts studied individually. It is this separateness in our exploration of structure that keeps us from seeing the big picture. In a synergetic whole system, essential parts know their exact relationship with each other. Change one and all the others change in unison to maintain a constant relationship. To lay a foundation for understanding the practical aspects of synergy, we will define the big picture of fundamental structure and what are the essential parts. The self-organizing modular building patterns found in nature grow out of the interconnectedness of these two ideas. New Tools Geometry defines 20 geometrical systems as the big picture of fundamental structure. To simplify our explorations, we will use the most effective minimum expression of this big picture, the synergetic 10. These 10 systems will provide all the information we need to find any structural numerical constant that interconnects basic geometry into one synergetic whole system. We begin to build our understanding of the interconnectedness of the essential parts by dividing the synergetic 10 into two basic job descriptions, the sphere and bubble families. There are 6 systems in the sphere family. Its main job is, when stacked together, to fill all of the space without gaps. This traditionally has been called the all-space-filling polyhedra. The bubble family's job is to form an outside protective layer like an eggshell or a cell wall. Traditionally, this has been called the fivefold symmetries because the number 5 is found in their construction. The other unique characteristic of this family is the golden ratio and its multiples are used in the initial construction. This is not found in the sphere family. The 6 systems of the sphere family combine in several ways to fill all space. Some do it by themselves, some in pairs, and some with a 3-way interconnectedness. This gives us a way to begin to understand how the essential parts fit together into one whole synergetic system. The tetra-octa combination fill all space. Inside any tetra is a half-size octa. Dividing the edge in half, or 1/3, reveals the interconnectedness below the surface. The rhombic dodecahedron, R-dodeca, is a unique example. We learned earlier that this system is the outside containment field around a sphere. R-dodecas fit together like closest packed spheres, so they are both closest packed and all space filling at the same time. The R-dodeca defines the space between the spheres and modular units. The bubble family fits together in interconnected layers, with the icosidodeca at the innermost layer and the triaconta at the outer layer. The icosa and the dodeca interpenetrate each other to provide reinforcements to the structural weak points of the inside-outside layers. This gives us a very strong structural integrity to this layering system. Natural modular building techniques color coordinates 5 basic shapes. Each color represents the fundamental information embedded in that shape. The 60-degree triangle is yellow and exists in both families. The sphere family combines it with the blue square and the green sphere diamond. The bubble family uses red pentagons and orange bubble diamonds in combination with the yellow 60-degree triangle. These two distinct color schemes allow for quick recognition of an unknown structure. The core design aesthetic of design in nature is do more by using less. A fundamental example of this is using the self-organizing abilities of spheres to define these two families. It begins by asking what is the minimum number of spheres needed to form a closest packed layer around our central U-Me ball. The answer will always be 12. The centers of these 12 spheres form the outside corners of the 14-sided vector equilibrium, VE, which I use as a symbol of the sphere family. Take the center sphere out, and these same 12 spheres rearrange themselves into the 20-sided icosa, a symbol for the bubble family. Designing like nature reveals building patterns that do more by using less. The next videos will take a deeper dive into the communication networks that connect the essential parts into one synergetic whole.